Welcome back to another exciting episode of Pre-Calculus Virtually, Section 8.3, Algebraic Solutions to Trigonometric Equations. This is Part 3. Okay, have a close look at Example 8. Okay, yuck. It may be tempting to divide by tangent on both sides. Don't do that. That seems like a good idea, but if tangent of x is equal to 0, which is possible, then dividing by 0 on both sides totally messes things up. We end up losing some of the solutions. Alright, so instead what we're going to do is we're going to put everything on one side and factor. Alright, so we'll subtract that tangent over from the left side, from the right side, sorry, over onto the left side, leaving us with nothing on the right side. Then we'll factor out that tangent. And we'll have tangent times cos squared x minus 1 is equal to 0. Now we have two factors. Each one can separately be equal to 0. What if the first factor is equal to 0? Tan x equals 0. We know that tangent is equal to 0 when x is equal to 0. But if we look at our unit circle and think about how tangent is defined, it's also 0 when x is pi. Okay, so we have 0 plus or minus 2 pi n, pi plus or minus 2 pi n. That really boils down to just pi n, where n is any integer. Okay, think about it for a minute. If n is 0, if n is 1, if n is 2, then that's this plus 2 pi. If n is 3, that's this plus 2 pi. And it's just going to go back and forth like that. Okay, so this is the best way to summarize those solutions. The other solution set comes from the other factor. Okay, we know what to do with this. Isolate the trigonometric part. Take the square root of both sides. Now watch out here. When you take the square root of 1, you could get plus or minus 1. Okay, so we have to think about where is, that's now been square rooted, sorry. Where is cosine of x 1? Well, that's when x is 0. Where is cosine of x minus 1? Well, interestingly enough, that's where x is pi. So in the end, we do get the same solutions. I suppose we could have divided by tangent and gotten this right, but we would have been lucky this time. It's not always going to work out that way. So again, adding 2 pi to either of these, we end up with the same answer, and this is the best answer for the whole problem. Okay? Pi n. So have another look at that. If you need to, pause it, and we'll try another one. Okay, this last one is probably the most complicated of all that you've seen so far. Example 9. It's going to bring into it substitution again, but it's also going to bring into it a trick that we haven't seen for a while. It may be fresher in the minds of Justin, Sigrid, and Layla since you guys have been working with the identities more than the others. Okay, look at that. Substitution seems like the way to go. It's sort of a quadratic thing, but what's wrong? We've got sines and cosines. So what do we pick for our u? If we pick it to be sine of x, that doesn't help us much here. So before we do that, we need to figure out a way to turn this into something to do with sine of x. And the way to do it is to take advantage of this good old Pythagorean identity. Okay? So cosine squared of x is the same as 1 minus sine squared of x. So we're just going to replace cosine squared of x with this. Negative 10 1 minus sine squared of x minus 3 sine x plus 9 equals 0. Expanding this out, distributing this multiplication and consolidating, we're going to end up with the minus 10 and the 9 give us the minus 1. Alright, now we're in business. Now we can say, hey, u is sine x, like we did before, and this turns into 10u squared minus 3u minus 1 equals 0. Okay, that's easy enough to factor. 2u minus 1 times 5u plus 1. I think that checks out. This means that u is 1/2, and this means that u is negative 1/5. This we can handle without a calc. For this, we definitely need the calc. We need to do the inverse sine of negative 1/5. Okay? We get a whole ton of answers with this. This means that the sine of x is 1/2, right? Because u is the sine of x. So sine of x is 1/2. That gives us pi over 6 and 5 pi over 6 plus 2 pi n plus 2 pi n. So that takes care of this factor, this branch of the solutions. This guy is messy. Okay, we take the inverse sine of negative 1/5, and we get minus 0.2014. Now that's a fourth quadrant answer. We also need a third quadrant answer. To find that, we have to do the same kind of things we did before, and we end up with pi plus 0.2014, or 3.343. Okay, so we have two answers and two more answers. Sets of answers, right? Okay, so if you could follow all that, you're going to be just fine with the work to come. I'd like you guys to do the following work. Page 545, 1 to 53, every other odd, and number 55. Okay? Good luck. If you don't understand some of them, please send me an email, find a way to contact me, and I will do everything I can to try to help you guys with this. Okay? Don't be shy. My job here is to help you guys out. So please send me email, send me messages somehow, and we'll work this out. All right? You can also work together and try to explain it to each other. Good luck, and see you next time. Kolpak out.